Assalamu alaikum dear students. Today in the online class we discuss the isotopes and a very important topic related with the isotope, and that topic is relative atomic mass. Actually the word iso means same and top mean place, so atoms of the same elements which have same atomic number but different atomic masses, they are known as isotope. The second definition, which is a very simple definition as compared to the first one: the atoms of the same element which have same number of electrons and proton but different number of neutron. So we can define isotope in two ways. We discussed some examples of the isotope. The very simple example of the isotope is of hydrogen. Hydrogen actually hydrogen has three isotopes. In the case of first isotope, and that isotope is known as protium. The protium is the first isotope of hydrogen, which contain one proton, no neutron and one electron. You can observe that in this example the electron and proton are same but the neutron is different, and it's the way how we represent the protium. In this example you can see that the hydrogen, the symbol for hydrogen is H. The atomic number which is below the symbol is atomic number, and the one which is above the hydrogen symbol is the atomic mass. So atomic number 1 and atomic mass 1. The second isotope of hydrogen is known as deuterium. It is also known as heavy hydrogen, and in this situation you can observe that the proton is 1, electron is 1, but neutron is 1. In the previous case we discussed that there is no neutron in the protium. However, you can observe that there is only one neutron in the nucleus of the deuterium. In this example, in this isotope we can represent that this isotope as H1, 2, 1 is the atomic number, 2 is the atomic mass. So they have the same atomic number H1 and H1, but the atomic masses, they are different. Here the atomic mass of hydrogen is 1 and here the atomic mass is 2, because proton 1, neutron 1 give you 2. The third isotope of hydrogen is known as tritium, and in this situation you will notice that the proton and electron is 1 but the neutron, they are 2. So the atomic mass in this situation will be 3. For that reason tritium is represented as this. 1 is the atomic number, 3 is the atomic mass. So with the help of these examples we come to the conclusion that they are the atoms of the same element which have the same atomic number but different mass number. In these examples we can also observe that the number of electron and proton are same in three examples, but the number of neutrons, they are different. In the second case we discussed the examples of carbon. Actually the carbon has also three isotopes. In the first example we can observe that the protons, they are 6, electrons which are indicated with a blue marker, they are 6, but the neutrons, they are 6. The atomic mass in this situation, 6 plus 6 will give us 12. 6 is the atomic number, so atomic number 6 and atomic mass in this situation is 12. So this is the first isotope of carbon. In the second situation, in the second example we can see that the protons, they are 6, electrons 6, but neutrons, they are 7. So 6 plus 7 will give us 13. So the atomic mass in this isotope of carbon is 13 and the atomic number is 6. Similarly, in the third situation, the protons, they are 6, electrons are 6, but neutrons are 8. So when we add protons and neutron, that is 6 plus 8 will give us 14. So atomic mass is 14 in the third situation, and atomic number remains the same because the number of protons, they are 6, so atomic number will remain the same. So in all three examples we can notice that the atomic numbers, they are same, but atomic masses are different because of the number of neutrons. After that we discuss the relative atomic mass, and the relative atomic mass is a particular term which is related with the comparison of atomic masses with some standard. Actually the atomic mass is the mass of the atoms which are very, very small, so we can't measure the mass of these atoms simply or directly. For that reason we relate the atomic masses of atoms with some standard. As in our life we take some standard for measuring the mass of different substances in the life. So in this example the relative atomic mass is actually the comparison of the atomic masses of different atom with standard, and in that situation the scientists select carbon 12 as a standard for the relative atomic mass. Why scientists or we select the carbon 12 as a standard? Because carbon is the most abundant element in nature, which is present in nature. So the second reason for chosen carbon as a standard of its moderate reactive nature. It's not very reactive, not an inert element, so the reaction of the carbon is very moderate. At that time when the carbon is selected as a standard, at that time there is no isotope of carbon for that reason, because of its only one isotope of carbon, we select the carbon as a standard. Now what is relative atomic mass? Relative atomic mass of an element is a mass of an atom of an element relative to the 1/12 of mass carbon 12. So actually we are talking about carbon 12. So this is our standard. Standard mean that we compare all the atomic masses of atom with the carbon 12. We represent this diagram is for the representation of the 12 units of carbon. If you count the number of the blocks, they are 12. So this is the carbon 12 atomic mass. But for the comparison, for the relative atomic mass, we take a part of that 12. So for that reason we use 1/12 part. So carbon 12 में से आपने एक पार्ट कार्बन का लेना है, उसको कंपैरिजन के लिए हम यूज करेंगे. So relative atomic mass is actually the mass of an element is the relative atomic mass of an element is the mass of an atom of an element relative to the 1/12 of carbon 12. So we compare all the atomic masses of atoms of elements with 1/12 part of carbon 12. So this is all about the relative atomic mass. That's all for today. Thank you.